Hi students, today we'll discuss about complete overview of the power amplifiers. Complete overview of the power amplifiers, very important. If you watch this video, you can able to write minimum 50% to 60% answer for each and every question which is related to power amplifiers. So listen carefully. Power amplifiers complete overview. Based on position of the Q point. Already we know what is Q point. If you draw DC load line, this is DC load line. On output characteristics of the amplifier. This is DC load line. The center of the DC load line is our Q point. This is Q point. Center of the DC load line is Q point. If it is in the active region, that is operating acting as amplifier. If Q point is moving from active region to saturation region and active region to cutoff region like that. Then based on those moment of the Q point position, these are classified as based on the position of the Q point. Power amplifiers are classified as first one is class A power amplifier. Class A power amplifier. If the Q point is at the center of the DC load line or in the active region, if the Q point is at the active region, that is called as class A power amplifier. Again, class A power amplifier is further classified into two types. One is series fed or direct coupled class A power amplifier. Series fed or direct coupled class A power amplifier. And then second one is a transformer coupled class A power amplifier. Series fed or direct coupled class A power amplifier. Second is a transformer coupled class A power amplifier. So if you see this for the series fed or direct coupled, the efficiency is 25%. If you calculate efficiency, output power by input power, PAC by PDC, the percentage is 25. That is the drawback in series fed or direct coupled class A power amplifier. That drawback can be overcome by transformer coupled class A power amplifier. If you are coupling with a transformer, then you will get efficiency as 50%. 50% for transformer coupled class A power amplifier. These two separate videos are already available. You can watch there the efficiency derivation. Similarly, class B power amplifier. Class B power amplifier. If you see that if the Q point is moving towards cutoff region, that is a class B power amplifier. Then the efficiency of the class B power amplifier is 78.5. 78.5 is the class B power amplifier efficiency. Here this is the diagram of the class B power amplifier. Class B power amplifier. If you see this class B input transformer and output transformer, both emitters are connected together. We are using two transistors Q1, Q2. Both transistors connected together, and here we are giving supply in between the two transformers, input transformer and output transformer, and two collectors are connecting to the two collectors are connected with the primary of the second output transformer, and across load resistor we are taking the output. This is push pull, class B push pull amplifier. In class B power amplifier we are getting efficiency 78.5, and we are giving input signal like this. Input sinusoidal signal we are giving, but at output side we are getting output crossover distortion like this. Output is we are getting crossover distortion in class B power amplifier. Input some delay and output. This is output signal on x-axis we are taking. So positive peak output, some delay. For the negative peak output, some delay and positive peak like that we are getting. This is called crossover distortion. It is taking some delay. So in class B power amplifier, we are giving smooth sine signal. We are getting output, but there is some distortion in the output. That is called crossover distortion. This is not pure smooth sine signal. This is the drawback in class B power amplifier. It is giving 78.5 efficiency, but the output is not pure sine signal. So then this can be overcome by class B power amplifier. This is the class B power amplifier. Again another category, class AB power amplifier. Input signal. Here we are using two diodes. For each positive peak one transistor will on. For the negative peak another transistor will on. This is the NPN. This is a PNP transistor. Each cycle one transistor will on. Then you will get output like this for positive peak. Similarly for negative peak Q2 will on, you will get output like this. Smooth output will get in the class AB power amplifier. This is giving efficiency as 78.5%. same as class B. Similarly, last one, class C power amplifier. Class C power amplifier. This is a circuit diagram of class C power amplifier. Input we are giving, and this is a C configuration. There we are using on tank circuit, and this is coupled just like a transformer coupled amplifier. This is C and L tank circuit. VCC applied. Another supply VBB also we are going to give. VBB is a negative. Negative. If you give input signal like this, two supplies we are using. Then output across RL we are taking output. We are getting 180 degree phase shift. If you calculate the efficiency, percentage of efficiency is PAC by PDC. Then PAC value is VCC minus VCE saturation into IDC, and PDC value is VCC into IDC. Without giving any AC input signal, output is power is VCC into IDC. That is a PDC. When we give some input signal, the power is VCC minus VCE saturation into IDC. Then here in the numerator I am taking VCC common. 1 minus VCE saturation by VCC. We will get this. So this VCC will get cancelled. This IDC will get cancelled. Then if you see this 1 minus VCE saturation by VCC compared to VCE saturation value, this value is very high. VCC is very high. So low value by high value, then this will be negligible or zero. So 100 into 1 you get 100% efficiency. 100% efficiency. This is the class C power amplifier. This is the derivation for class C power amplifier. Very important one, and it will give more efficiency. This is overall classification of the power amplifiers. Class A series fed or direct coupled 25%, and class A transformer coupled 50%. Class B 78.5. Similarly, class A is 78.5. Class C nearly 90 to 100. If you are taking VC value and VCC value 12 volts, if you substitute, you may get 90 to 100%. 90 to 100%. This is about classification. Later, because of these power amplifiers, these are operating with high power. Because of this high power, there will be some more power generation, more heat will be generated. Because of that, the device may get damaged. So that is called thermal runaway. So that thermal runaway problem can be avoided by using heat sinks. So heat sinks is the continuation topic in the power amplifiers. Maybe you can use large power heat sinks or low power heat sinks. You can eliminate the power dissipation and you will get smooth outputs. This is about the complete power amplifiers. Very easy way you can understand, and you may write minimum answer for circuit diagram, description and efficiency. Later by watching remaining videos you may get a derivation for efficiency. Thank you.